In today's video, I'm going to show you a high-value power station that can do some real heavy lifting. Hello everyone, my name is Dan, welcome to Freely Roaming. One of the often debated questions that people have about a small camper build is whether to do a DIY electrical system or just buy a power station. Now in the past I've reviewed some power stations that are in the mid-size range. It has roughly 500 watt hours of capacity and the built-in inverter can power up to 750 watts of output. So I've got a power station now. It is on the high end of the size. This one is the OUPES 1200 watt power station. This class of power stations is about the size of power stations that you can use for everyday use in a small camper. If you have limited space and have relatively low consumption needs, this power station will be perfect for you. And the prices of these have really come down. Now the power station market these days is really saturated with tons of choices. There are a lot of companies that have started to make them, and some of these names that aren't super popular household brands, but that's mostly because they don't spend a lot of money marketing. And all the money that these big companies are spending on marketing has to be paid by basically consumers that buy the product. So that's why you can buy a product like this Opus 1200 watt power station for a significant discount compared to some of these bigger names. Some of the more popular brands like Jackery, EcoFlow, and Blue Eddy, their newer products have higher end features like Bluetooth connectivity or Wi-Fi, mobile apps, also things like extendable battery modules that these lesser known ones don't have. But personally, it's not that big of a problem for the use case of one of these power stations. That's not really that necessary, mostly because if you're going to use this in a small camper van, it's basically going to be within arm's reach constantly. I have played with those other power stations that have mobile apps. I don't actually find myself using it very much. And also, if you wanted to have extended battery modules to go with your power station, chances are you're not limited in space. And you may as well just build your own system or just buy a bigger power station in the first place. Compared to DIY electrical systems in camper vans, power stations, unless they're constantly connected to solar or some kind of pass-through charging system, they're going to go through a lot of charge cycles, more so than a typical electrical system built into a camper van. And that's because in a camper van, especially when you have solar constantly hooked up, every day sun is charging your batteries. And the deepest depth of discharge you're going to experience is overnight. At nighttime, when most things aren't turned on, the only thing that you're going to have draining your battery in a camper van is probably just your refrigerator if it runs off of 12 volt. So you'll wake up to a battery that's partially discharged, but as soon as the sun comes out, it's going to start charging again. Now, battery stations, on the other hand, depending on how you use them, people tend to use these portably. They'll take these with them wherever they go. Chances are not plugged in, and then people will just use them until they drain completely. And it's more likely that power stations like this will experience more 100% to 0% charge cycles. Because of that, I look for lithium iron phosphate batteries in these power stations. Lithium iron phosphate battery is what I would use in a built-in electrical system anyways, but I think it is especially important for power stations to have those. And that's because the high cycle life that they're going to get. The other things I look for in a power station are things like a regulated DC output and also pass-through charging. Now, with lithium iron phosphate chemistry, as long as they're using a 4S system, which nearly 100% of all lithium iron phosphate power stations are going to use a 4S system because that creates the most ideal 12 volt battery pack there is. In that case, a regulated DC output is not quite as important. But if a manufacturer is going to use a lithium ion system, chemistries like nickel, manganese, cobalt, 4S is too high a voltage on the high end, but 3S is too low a voltage on the low end. So a regulated DC output is more important for those chemistries. Before I show you guys the product testing that I did for this OUPES power station, let me just go through some specs and show you a little bit about how this works. This portable power station is rated for 1200 watts of output. It has 992 watt hours of capacity. Of course, that is the battery capacity that's inside this power station. That is not going to be what you're going to be able to get out of it when you do a capacity test. All power stations are like that. My expectations for power station is to reach at least 80% of its rated capacity during DC and AC output tests. And then we'll see in the test if this one passes. This has a 1200 watt pure sine wave AC inverter with a surge wattage of 3600 watts. It has 3 AC outlets, a power button here, a DC input plug that you use for both solar as well as your AC charging plug. So it's all charged through the same port. A lighter adapter, 2 barrel ports. I believe those are 5521 barrel ports, rated for 10 amps each. A USB-C power delivery 60 watt port, and also a second USB-C power delivery 18 watt port, and 2 quick charge 3.0 USB-A ports. In the back, of course, we have a flashlight. You have your constant on, you have your high, SOS, as always. Here's what the LCD screen shows. It shows you a battery state of charge meter, which shows you in the percentages as well as a graphical layout in this kind of circular form in these blue dots. So there are 1, 2, 3, 4, 5. There are 6 blue little segments of that circle. So as it goes down, it'll start to show you how much is depleted. I personally like the percentage number better because it's more accurate, it's more precise. Each side has its own switch. So the AC side, you press and hold. You can turn on the AC side, and also on the DC side, you have a similar button there that you can press and hold. Over here on the left side, it shows you how many estimated hours are left based on the current draw. 99 is the highest. And over here on the side, it'll show you both how much power you're putting in as well as how much power you're drawing out. There's a fan here on one side and also a vent on the other side that lets air come through. So it'll do a pretty good job of cooling. When it's drawing a lot of current, airflow can come right through this and cool this down. It is kind of loud, but that's to be expected. It comes with a AC wall charger. Let me read that for you. 100 to 240 volt input. The output is 26 volts at 4.75 amps, which has a max output wattage of 123.5 watts. With that AC adapter, it'll take up to 6.5 hours to fully charge this battery bank. Or you can charge using 2 solar panels. You can charge with up to 200 watts of solar. It'll take 8 hours to charge with 2 solar panels, 200 watt solar panels. And it'll take 12 hours to charge using a car 12 volt adapter. With that said, let me show you how the testing went. This is a 1200 watt rated sine wave inverter in here, so let's keep going. Let's go medium. Now we're drawing 826 watts, right about 800 watts on the power station. Still going good. Let's go medium high, see what happens. There it goes, 1000 watts. You can hear the fan start kicking in here. So far it's surviving. Let's see how much power we've used. 0.016 kilowatt hours, not much. Only about 10 amps. Okay. Let's go to high. This might kill it. High. Now we're over 1200 watts. Fan is on full blast. Still going. That's actually pretty good. So we're gonna have to do the boil test on high probably, see if it can survive. And let's go to max. It'll probably kill it then. Max. Going up to 1300 watts. Still going. And that power meter is going down fast. It's doing 1300 watts for a 1200 watt inverter. So maybe we'll do the boil test on max and see if that passes. You see a little steam coming out already. Okay, I spoke too soon. It didn't last on the max mode, so that tripped the inverter. So I have to turn that off and get it back on. Okay, I think high is the most we can do here. Let's see if we can get this to trip on high mode. It'll do high. Well, it's gonna boil. Alright, now I'm doing a capacity test using the AC outlets. So I'm actually using this battery charger to charge one or both of these batteries from here. Probably not going to charge both. Actually, definitely not going to charge both, because there is enough capacity in here to charge even just one of them. But that should give me a good load. Right now it's pulling almost 500 watts. And here on the AC power meter, it's pretty close. 46 and a half, 44 over there. So this should take probably about 2 hours to completely drain, and then we'll see how much capacity we get out of it. So far it's already pulled 34 watt hours in a little less than 5 minutes. 608 watt hours down. I've got 32% left. And this battery bank is rated for 992 watt hours. So this is going to be short, but that's expected. The question is how short. We'll see. Hopefully we hit 900. But I suspect we might fall a little short. We'll see. This is the Opus AC discharge test in progress. So starting at about 6% in the remaining capacity, the battery bank is starting to trip, and I thought it was at first that I was pulling too many watts from the inverter, which is about 480 watts. So I switched over to a lower draw. This pulls about 200 watts. And it drew it down to 4%, and then now it's tripping again. So I suspect what's happening now is that we're going into low voltage fault mode on the inverter. 3%, so I think it's not gonna last. So keep in mind, for the Opus power station, at around 6%, you'll start getting this low voltage fault. I assume that's what EOO2 means. So that means we're at a final AC draw capacity of 853 watt hours. And the last remaining 3% just can't be used for AC because the inverter doesn't like it. All right, this morning I'm starting the Opus DC discharge test. I'm starting at 100%, and I'm pulling 10 amps, which is, I believe, what this is rated for. Max output through the DC port. So lithium iron phosphate chemistries actually are really good for 12 volt consumption, because it lives in a really comfortable range for most 12 volt devices. But we'll see what this voltage dips down to on the bottom end of the range. We're down to 42% here. Our DC discharge test, 11.5 volt. And it's actually holding the voltage pretty well. It is at 488 watt hours. We'll probably have we're 4 hours in, probably another 3 hours to go on this. Alright, this test is done. We are at 0%. This finished just shy of 7 hours. And we have 810 watt hours. 69.46 amp hours. So this being a 992 watt hour capacity battery, this is at just about 80% that we got out of the DC. So we'll see how that compares with the AC discharge test. So there you go. Let me tell you a bit more about what I think about this power station. I actually really like it. I was surprised how much AC output this can handle. Of course, it handled up to 1200 watts, no problem. And in fact, it handled a bit higher. I really like the LCD display of how the data is shown. Being a more budget-friendly system, it doesn't have all those fancy features. As far as the styling goes, I like this kind of layout, the front panel, but I'm not a huge fan of this orange color that manufacturers keep using. And as you can see, I'm wearing my orange jacket to go with this. It seems like hazard orange is what all these manufacturers have decided was the color of choice. Maybe the high visibility is the reason for that. But I do wish that this came in a more subtle color. This orange does have a rubberized feel to it, which is kind of nice for maybe absorbing some bumps, when you carry this around. But otherwise, it's a pretty no-frills power station. A couple of the features that I wish it had that it doesn't have, but I really can't blame them for this price range. I wish I had USB-C PD100, which means I wish it had 100 watts of output in the power delivery. And some of the newer power stations also have bidirectional USB-C now, which means you can charge through them as well. This one does not. Taking 6.5 hours to charge is a little slow. It has the ability to charge slightly faster if it just came with a 200 watt charging brick instead of a 120 watt charging brick. And lastly, I wish more power station companies included wireless charging for devices like this. It would be really nice if there was a wireless charging pad sitting right here on the top so I can place my phone down here, when I'm using this power station. I'm often using these power stations with my computer, so if my computer's plugged in, this is just sitting there on the table that I'm using my computer at. I like to be able to just stick my phone instead of having to bring another cable to plug in my phone to charge it while I'm using my computer. But for $700, you can't really ask for more than what you get out of this Opus power station. I'm really impressed with it. And in fact, if I was going car camping, this is probably the exact power station that I would get. Because of its lithium iron phosphate chemistry and also the ability to put out so much power, I can use an induction cooktop if I wanted to. So that's pretty much it. If you have any questions, feel free to ask them in the comments below. If you want to find out more about this power station, I'll put links to the manufacturer as well as where you can buy one for the best deal possible down there as well. Thanks as always for watching. Hope you guys are enjoying your day. I'll see you guys in the next one.